Hi, my name is Dana, and in this presentation, I will explain my final project titled Phishing Website Detection with Rockset Models and Analysis of Discretization and Uncertainty. So, phishing remains one of the most persistent cybersecurity threat, and while many modern detection systems achieve high accuracy, they often rely on black box model that provide little insight into why a website is classified as phishing. This project explored an alternative perspective, interpretable, rule-based detection with explicit handling of uncertainty. So, phishing websites evolve rapidly and often closely resemble legitimate domains. This creates borderline case where sharp decision boundaries are difficult to define. Deep learning models perform well in many benchmarks, but they are typically difficult to interpret, computationally expensive, and unsuitable for contexts where transparency is required, such as education, auditing, and security analysis. Therefore, this project focuses on not on outperforming deep learning, but on understanding system behavior, decision boundaries, and uncertainty representation. Rockset theory or RST is a mathematical framework designed to handle vagueness and indiscernibility in data. It classifies objects using lower approximation representing certainty, upper approximation representing possibility, and boundary region which explicitly capture uncertainty. A key advantage of RST is that it generates explicit if-then decision rules, making the classification logic transparent and inspectable. However, classic RST relies on hard discretization on continuous feature, which can introduce rigid decision boundaries and sensitivity to discretization choice. So, phishing dataset contains many continuous features such as URL length and character frequencies, which vary gradually rather than discretely. And to study how discretization affect rogue set behavior, I implemented three discretization strategies. The first one is equal with discretization as simple and transparent baseline. The second one is equal frequency discretization, which adapt to data distribution. And the third one is entropy-based discretization, which use class information to improve separability, and all methods were evaluated within a single unified pipeline using the same dataset, preprocessing steps, and trend test split. This ensured that observed differences are caused by methodological choice, not experimental bias. To address this limitation of hard discretization, I introduced a fuzzy similarity-based extension inspired by Rob set concept. Instead of crisp equivalence relation, this approach used similarity measure, produce soft decision boundaries, and assign its instance a degree of uncertainty, and a formal fuzzy rockset model require constructing a complex similarity matrix, which is computationally infeasible for a dataset of this size. Therefore, a key nearest neighbor-based fuzzy rock approximation is adopted to model local uncertainty without computing global fuzzy relation. This approach prioritizes scalability and uncertainty modeling but does not generate explicit rules. So these are the pipeline we talk about. The experiments were conducted on balanced phishing dataset with 10,000 instances and 49 features. So here the key findings includes first one is entropy-based discretization achieved the best balance between accuracy, boundary behavior, and rule complexity among classical RST methods. Second one is equal with discretization produce a larger boundary region, highlighting uncertainty but with lower performance. The third one is equal frequency discretization minimized boundary regions but resulted in fragmented and complex rule sets. And the fourth one is the fuzzy similarity-based extension achieved the highest accuracy and provided smooth uncertainty representation at the cost of explicit rule uninterpretability. This research highlights a clear trade-off between rule transparency and uncertainty-aware confidence. So these are the rule complexity comparison and the rule generation result. So in conclusion, this project demonstrates that row-set-based method remain relevant for phishing detection in contexts where transparency and controllable system behavior are important. Classical RST is well suited for rule-based explanation, especially with entropy-based discretization. Fuzzy similarity-based approaches are more appropriate when uncertainty modeling and decision confidence are prioritized. Rather than competing with black box models, this work emphasizes interpretability, uncertainty awareness, and engineering trade-off. So thank you for your attention.